All right, welcome back. This is where we left off on the last lesson, trying to find the volume and surface area of ridiculous three-dimensional shapes with cutouts. As you recall, we found the surface area and volume of this shape last lesson. Just a refresher that when you have a cutout on a shape, you have a decrease in volume. You have a lower volume than you regularly would without the cutout. That just is common sense. And you actually increase the surface area most of the time. You don't always increase the surface area, but generally, probably 95% of the time, you're going to have an increased surface area because you have more surfaces inside the shape. Today we're going to try a couple of more difficult shapes, especially weird shapes that you're going to see from time to time, especially if you're taking honors next year. If you're taking honors math, then you're going to want to try questions like this. I'm going to go through two of them today. The first is a triangular prism. It's an obtuse triangle. It's bigger than 90 degrees. It's weirdly shaped, and it has a, looks like a square prism cut out of it. So let's start off with the easier of the two. Let's start off with the volume. See if we can calculate that. And then we'll do the surface area afterwards. Because in order to find the volume, you got to find some of the surface area. So for example, on this one, I would start with the triangle, because we need to find the surface area of this. We've got the base of 14 and the height of 14. So remember, to find the area of a triangle is half the base times the height. So I need 14 times 14 and then half of that. So 14 times 14 is 196, and then when I divide that by 2, don't forget to cut it in half, is 98. If you forget to cut it in half, you're going to get 196, which is way too much. So I got 98 is the triangle, but now I need to subtract this little box right here, and you know the dimensions of this box is 3 by 3, and 3 times 3 is 9. So I'm going to take 98 and subtract 9. Which gives me 89 would be the area of the front and back. So I'm going to write that down as 89. I'm going to ditch this stuff and write down 89. And now I've got the front and back panels that I'm going to add for my surface area later. But for the volume right now, I just take the 89 and I times it by 25, and I'll have the volume. So it's much easier to find the volume because I got to find the area anyway at the front. So 89 times 25 gives me a volume of 2225 centimeters cubed. Because we're in the third dimension, so we have to the power of 3. Now, surface area. Well, I've already got the first 2 panels of the surface area, so I've got a head start. All right, so let's find the area of the other panels. I'm going to continue with the outside panels. So the first panel I'm going to deal with is the bottom, which is 14 by 25. Again, use your calculator if you need to. That's 350. I'm going to write it right down in the panel. I'm going to add it here to my list. The next one I'm going to find is this giant hypotenuse, which is 21 times by 25. So use your calculator again for that, unless you know what 21 times 25 is. 525. And then finally, you need the backside, which is 16 by 25. Maybe you can do that in your head. It's an even 400. So those are the outside panels of the shape. Let's get rid of those. I don't need them anymore. Because now I'm looking for the inside panels. And luckily for us, they're all the same because they're rectangle. It's a square, sorry. So it's 3 times by 25. And 3 times 25 is 75. So each of these panels is 75, and I've got 4 of them, top, bottom, side, side. So I'm going to add 75, 75, 75, and 75, or 75 times 4. So let's add all of those up, and we will get the total surface area of this shape. 89 plus 89 plus 350 plus 525 plus 400 plus 75 plus 75 plus 75 plus 75, and I get 1753 as my surface area. So that's, as long as I didn't screw that up on my calculator. I'm not going to double check it, but I'm assuming that I didn't mess up centimeters squared, because now I'm in 2-dimensional because I made it flat. So there we have surface area and volume of this triangular prism with a square prism cut out of it. Horrible. What happens if we have a circle cut out of it? And circle cutouts are probably the most difficult. I'll do this together with you, and then we'll stop there for today. But let's start out with the volume. That's the easiest. Let's find the area of this rectangle, which is 20 times a height of 15. So 20 times 15, I'm not sure why I'm calculating that, because I know that it's 300. And the area of the circle, again, it's got a diameter of 6, which means it's got a radius of 3. To find the area, that's pi r squared. That means the radius squared is 9 times pi. 3 times 3 times pi is 28.26. So I'm going to say it's 28.3. It's going to be difficult because now I've got decimals, but now I've got 300 minus the circle, which is 28.3. 271.7. So I'm going to write that down on the back. And I don't need that anymore, the stuff here, so I'm going to write it down on the front too, 271.7. Now remember, to find the volume, that's easy. I'm going to do 271.7 and times that by the depth, which is 50, and that will give me the volume of this shape. Again, it's the area of the front times the depth. 13585. So volume is 13585 cubic centimeters. Surface area, well, that's more work. In fact, it's going to be a lot of work on this one because it's a cylinder. But let's add up the sides that we know so far. We've got 271.7 and 271.7 is the front and back. Okay. Now we got to get the sides. So the sides of the box, well, that's 15 times 50. So use your calculator for that. That's 750 and 750 on each side. So add those. And top and bottom, well, that's 20 by 50. 20 times 50 is 1,000, so we'll include those. Top and bottom is 1,000. And now, this is the most difficult part, is we need to find the surface area of the walls of this circular tube. Remember, it's a rectangle rolled up to find the surface area of the outside of the tube. So we're looking for this rectangle that has been rolled up to make the cave that goes through this box. How do we find the area of that? Well, remember, before, we took it and unrolled that rectangle. We unrolled it, and when we unrolled it, it became a rectangle that was just rolled up in there. So that is it flattened. We already know that the length of it is 50, but we need to find this distance across the rectangle, which is the width. And how do we find that? Remember, it's the distance around the circle. How do we find the distance around the circle? We use the formula C equals pi times the diameter. That's 3.14 times 6 centimeters. So use your calculator. 6 times 3.14, 18.84. And I'm going to leave that in my calculator screen because it's already there. And then times that by 50. And that'll give me the area of that rectangle that's rolled up to make that tube. And I get 942. 942 is going to be, again, the area of this rectangle right here that was rolled up to make the tube. Yes, that seems like a lot to take in. So again, these 6 sides are the rectangle, and this is the walls of the cave on the inside, which makes that tube. I'm going to add all of those together to find my surface area. So that's 271.7 plus 271.7 plus 750 plus 750 plus 1,000 and plus 942. 4985.4. Centimeters squared. So when we had a box, when we had a square cut out of it, we had 4 sides to deal with. When we have a circle cut out of it, we don't have 4 sides anymore. We have one continuous side, which is a rectangle rolled up. And again, that is this part here in black. Well, it's also in black and red and green and blue. So all the sides added up, 7 sides, 942 is the last one. We'll stop there for today. We're going to try a couple of questions like this on the worksheet and see how you do. Good luck.